check your work for problem set 11. What did we start with?
Number 1.
1 is 1/4 inch. 10.
12.125.
Yep, 12.25. Usually with inches we'll use fractions, but 12.25 is fine. 10 is 4 feet. 11 is 49 pi square yards. 12 is 4. 13 is negative 20. 14 is 1. 15 is negative 20. 16 is 22. 17 is 6. 18 is 0. 19 is 0. 20 is negative 16. 21 is negative 12. 22 is 7. 23 is 14. 24 is 2/3. 25 is 0. 27 is 180 square meters. 28 is 35 square meters. And 29 is 63 square inches. Anyone answer? Any answers anyone wants me to repeat? All right. Anyone want to go over
All of them.
all of them? Well, we can't do all of them, but we can
Well,
do.
not like all of them, but like most of them.
Well, let's start with 1. Start with 1. That's a type of problem that you want to go over.
11.
11. All right. So 11. We're here on page 53 in the textbook. Number 11. The diameter of a circle is 14 yards. Find the area. Okay. So diameter is 14 yards. Area. How do we get the area of a circle? What's the formula for that?
The thing, 14 divided
Just give me the formula. Don't do anything to 14 yet.
b plus times pi squared divided by 2.
Area of a circle. Only one formula we have for it. Pi r squared. Right? Pi r squared. Now, the problem we run into is that we don't have r. We have what?
D.
We have d, the diameter, not the radius. So how are we going to get the radius? If the diameter is 14 yards, what's the radius?
Divided by 2.
So the radius is
7.
7 yards, right? Half the diameter. Now we can plug it into pi r squared. So it's pi times 7 squared. What's 7 squared?
7 squared, 49.
Yep, so we got pi times 49, or 49 pi. And then our unit is what?
Inch. Yards.
But since it's area, we don't have yards, we have
Square yards.
square yards, yes. 49 pi square yards. That's how we got that. So they give us the diameter. This is why I really recommend that you write down everything first. This is how I would write this out if I were doing this on a test. This is how I recommend you write it out if you're doing it on a test. Write the information they give you. Diameter is 14 yards. Area is pi r squared, because we're looking for the area. And that's our formula that we know. We look at that, we say, wait a minute, I need r for that, I don't have r. How do I find r? Okay, it's half the diameter, so radius is 7 yards. Then I plug in 7 yards for r in this formula here. Pi times r squared, pi times 7 squared. Get 49 pi. Okay, take it one step at a time, write things out for yourself. Other ones to go over.
20.
20.
What was it? The answer for that one was what?
I
got it.
should be negative 16.
Yeah, I want to go.
Yep, so 20. We've got negative 2 times negative 2 times negative 2 minus pi negative 8 pi. Is that correct? Did I write that correctly?
Mm-hmm.
Okay, so what do we want to start with?
Negative 2 times 2. Negative 2.
Negative 2 times 2, well, what do we have here? Negative 2 times,
Negative 2.
which is going to give us what?
Positive 4.
4 times negative 2, right?
Equals negative 8.
Right, so negative 8. Then we have this second part here, minus absolute value of negative 8. Now what can we do to this minus? How can we rewrite this to make our lives a bit more simple?
Plus negative.
Plus negative. Now what happens?
It's going to be a negative 8.
Why?
-8 in the pipes is gonna be +8 and then plus the negative.
Yes. So the pipes make this -8 +8, and then this negative outside that makes it negative. So we have -8 plus -8, or -16. And notice what you did correctly here is that you multiplied these together first before you did that addition. Following our order of operations. Actually, technically, following our order of operations, we do parentheses first. Remember that the pipes count as parentheses. So after we rewrite the subtraction as addition of a negative, we should actually do the pipes first. So first we do parentheses. We take out 11 so I can check it. We do the and then addition and subtraction. Okay, following the order of operations. Thank you. Anything you want to go over? Any others from this problem set?
Number 27.
27, all right. 27. Finding the area. Notice this is based on lesson 8, so this kind of problem is fair game for tomorrow's test. We've got one of these annoying L-shaped things. It's like one of those tetra shapes. All right, we've got 5, 8, 9, 14, and 18. And the unit is meters. They asked us to find the area. I should really draw that larger. Let me redraw it. For the guys at home watching on the green webcam.
Oh, I got. Oh,
What was that?
I just figured out what I did wrong.
Aha! What was that?
I didn't put the other one where 9 is.
Yeah?
Above 9.
You went like this?
No, I went like the other way.
You went the other way? Okay.
But like at the top of that square,
Yeah?
I didn't put the number.
So what is it?
I think it's 9. Hold on. Yeah, 9.
Not 9.
Because that's 18 and then. Yeah. Yeah, 10.
So yeah, it's 10. Because these two have to add up to that. We've got 8 here, and it adds up to 18, so it's got to be 10. So area of number 1 is going to be 5 times 18, 5 by 18, and area 2 is going to be 9 times that 10 there. So we get 90 there, 5 times 18, anyone?
90
Yeah,
plus 90
yeah,
equals 108.
yeah. And what's the unit?
That's square meters.
Yeah, square meters, there you go. Yeah, so with these ones where they're shaped like L's or whatever, just break it up into 2 rectangles of each rectangle, correct. Next. What's next? Today's a review day, primarily, so we can spend as much time going over the homework. After we finish the homework, I'll take questions about lessons 1 through 8, which are on the test tomorrow. And then if there's time, we'll briefly review lesson 12.
Okay. Number, yeah. 7 through 8 and some others.
So we skipped those, but we can go over them. So 7, yeah, let's go over 7 because,
Oh, never mind.
but let's do 7 because that's based on lesson 4, and that's fair game for the test. So they say use 1 unit multiplier to convert 25 meters
Oh,
to centimeters.
this is
All right.
the hardest.
Can we go directly from meters to centimeters? Is that a conversion that we can do, meters to centimeters?
Yeah.
How many meters go to how many centimeters?
I'm not sure. I should have.
I think it's 1 meter.
And I know.
I think it's 100 meters. Wow.
All right, let's review these. So metric Metric system. We've got a meter, right? A meter is 1 meter. Okay. A meter is a meter. A centimeter is 1/100 of a meter. A millimeter is 1,000 of a meter. We've also got a kilometer, which is what? Is 1,000 meters. So a kilometer, remember, is on the same sort of scale as a mile. Kilometer is about half a mile. A meter is about a yard. It's about just a little over 3 feet. So a kilometer, that's a long distance. It's 1,000 meters. A centimeter, we know that's a small thing. It's roughly on the same scale as an inch. There's 2.5 centimeters in an inch. A millimeter is even smaller than that. There's 10 millimeters in a centimeter. 100 centimeters in a meter. 1,000 meters in a kilometer. So, going between anything that has meter at the end is really easy. So meters to centimeters, we're not going to need to use more than one step here. When we're doing our unit conversions, how do I set it up? I want to go from 25 meters to centimeters.
Okay.
25 meters over 1. Make sure you write the unit there so that you keep track of where we're going to put everything when we set this up. All right, then what do we do?
Well, 1 centimeter.
What are we going to do next?
100 centimeters
Times, yeah, times what?
times, 25 meters times 100 centimeters
Over.
1 meter.
Yeah. So notice we want to get rid of meters. So meters on the top, so we have to put meters on the bottom so they cancel out.
Yeah.
We're going 2 centimeters, so we put centimeters on the top. These need to balance. 100 centimeters go into 1 meter. Meters cancel out. We're left with what?
100 centimeters.
25 times 100 centimeters. Or 2,500 centimeters.
I always forget that part.
Yep. Yeah, gotta get comfortable with these unit conversions. Next, from problem set 11. You wanna go, yep? You want the answers?
Huh?
You want the answers? So I read those out earlier. I can tell them to you later.
1, 2, 3, 4, 5, 8, 9, 6, 7, 5, 3, 8, 10.
Any others? Let's take a look. What about 29? What did you have to do for 29?
Well, let me see here. We need to. Oh, I get this one. It's the area. It's the area of the shaded portion of the figure, which is going to be 25.
So, we've got this donut-shaped thing. It's like a square donut. We want to know the area of the shaded part, just the shaded part. You think of it like a wall with a window in it. We want to know the area of the wall itself. How are we going to find the area of this? Do we have a formula for this weird square donut
I
shape?
think so.
What are we going to do?
25.
Where'd you get 25 from?
The 5's inside.
Okay, so let's name this space. What are we going to call it?
Little square.
Okay, we're going to call it square. Let's call it square 2. So square 2 is what? What's the area of that?
25.
25 what?
25 minutes. Meters.
Nope.
Square meters.
It's not meters.
Square meters.
Square what?
Meters.
Not meters.
It's where.
Kilometers.
Inches.
Inches.
Look at the problem. Oops. Sorry, I shouldn't have boxed it. Yes, 25 square inches for that guy. But did they ask us to find the area of the white space inside?
Yeah, the shaded space. No,
If it's white, is that shaded?
Space.
If it's white, is that shaded?
No.
No. That we're not finding that area. What area are we trying to find?
The shaded space.
The shaded space, how are we gonna find that?
25 minus 38.
88.
Okay, where'd you get 88 from?
So 8 times 11.
Okay, so this big thing here, we can call area 2. Or area 1, sorry. Area 1, that whole big rectangle is what?
88
Is 88.
inches.
Square
area
inches.
was the-
So the whole rectangle is 88 square inches, right? Now we want to know the area of that, but somebody's come along and cut this chunk out of it. How big of a chunk did they cut out of it?
25 inches.
25 square inches. So what's the area just of the shaded part?
Oh,
The area of the shaded part is what? How are we going to find that? You don't have to calculate it.
25,
Right, we're going to take the area of the whole thing
63.
and subtract the area of the piece that we cut out. So it's 88 minus 25, and yes, we get 63
Inches squared.
square inches, yep. So not only can we add areas together to find the area of a weirdly shaped thing, we can also subtract areas to find the areas of weirdly shaped things. Think of that as a wall with a window cut out of it, or a cookie with a bite taken out of the middle. You could do that for this guy also if you wanted. For one like 27, we could ask ourselves, okay, so we've got this big thing here. The whole thing is 18 by 14, and the bit that's been cut out is 9 by 8. Right, we could do that too. So 9 by 8 is 72, where we have square meters. 18 times 14, anyone?
18 times 14.
Yep. It'd be 252. Right, because it's 36 times 7. Yeah, 252 square meters. So it's like we had this big rectangle and then we cut out one of the corners. 252 minus 72 leaves us with what? Oh look, 180. And you could do that for this problem also. It'd be a little more awkward. But we could do that. Similarly, if you really wanted to, for this guy here, you could break up the shaded space into 4 rectangles. Right? We could say that this rectangle over here, well actually here we can't, we don't have enough numbers to calculate all these rectangles separately. But if you had more measurements, theoretically you could do that too. But the easiest thing for this one is going to be to find the area of the whole thing, find the area of the chunk we cut out, and subtract. Yes? With a problem like this, if you get a negative number, what does that mean? You did something wrong. Why? What would a negative area look like? Right, how can you get it? Well, so if you did 25 minus 88, for example, you'd end up with a negative number. It would be wrong, and you should be able to tell it's wrong because a negative area doesn't really make sense, except in the context of you cut a chunk out of something. But our final answer can't be a negative area, because how can you take a chunk, how can you only have a chunk taken out and not something else that's there? All right. Other questions from problem set 11 you want to go over? Everybody got number 28 correct? 35 square meters. How'd you get that?
Oh, because 10 times 7 divided by 2.
Right, because this is what kind of shape?
Let's try
It's a triangle. What's the formula for the area of a triangle?
length times base times height divided by 2.
Yep. 28. Area of a triangle is 1/2 base times height, or you could write it as base times height over 2. Anyway, 10 times 7 gives you 70 divided by 2. Yep.
I didn't show the work really,
Okay.
because I just looked at it.
Yep. Yep.
There was 70 and I divided it in my head.
Yep.
Would you and then I have it 35 meters.
In general, I ask that you show work on texts because if you don't, so first of all, with this kind of problem, it's clear that you don't need to have written down work to get the correct answer. So that's not like an issue for me. The issue is that if then you get it wrong, I don't have anything to give you partial credit with. If it's a problem where really there should be work, like you couldn't, it's not the sort of thing you could just do in your head, and I don't see any work, then I'm gonna have some questions. But a problem like that, do you actually have to write out your work? No. Do I recommend it? Yes. Because then I can give you partial credit. If you make a mistake, we can figure out where it was. You can figure out where it was. But no. Yeah, if you just wrote 35 square meters there, that'd be fine. But I do try to model for you guys how I recommend writing these out. So notice here, like for this triangle one, area is 1/2 base times height. The base is 10, the height is 7, so area is 1/2 times 10 times 7. 1/2 times 10, that's 5, times 7 is 35 per unit meters, square meters. That's how I would write this out. I recommend you do something similar so you have all your steps there. Notice I always start by writing down the information that they give me. No look for area, so there's my triangle area formula. Base and height. Sometimes it's even good to draw the diagram there for yourself, because then you can write on it. I always like writing in these, drawing in the length where I'm cutting it, and writing in the measurements that I figured out. So I have them there, I have that visual. All right, any others from 11 you want to go over? Going once. Going twice. Anybody at home? Want to go over one from set 11? Right in. This is your chance. All right, so I'll open it up now for questions about any lessons from 1 to 8. Anything you want to go over there? If there aren't any requests, I'm just going to run quickly through the material of 5 through 8. And then we'll probably do 12.
Order of operation for us.
Should be.
Yeah, no, I don't know. Is that what the test is going to be on?
So the test will be lessons 1 through 8. So it'll look like look like your last test. It looks like one of these problem sets where the problems are only based on the first 8 lessons.
No, I did that. I was happy to do it like
No. I don't have a practice test for you.
Okay, right.
But
Wait,
Mr.
so
Brown,
if I do lesson 8, will I have like the same problem?
Yep. Yeah, so the lesson 8 lesson set covers all that content. Or you could do 9 and you could skip the ones that say they're based on 9. Or you could do 10 and skip the ones that say they're based on 9 and 10.
Wait, are we supposed to have the test after 8?
No, so the test is always 4 lessons behind what we're going over in class. So today we're going to briefly go over 12, which is a very short lesson. And so test 2, which covers up to lesson 8, is after lesson 12.
Can I go back to the when is test? Or I mean, test 3?
Test 3 will be sometime next week, probably. Maybe the week after. Yeah, you can go quickly. Okay, so lesson 5, remember, we introduced sets, set notation, which will use the curly brackets, which indicates this is a list of numbers. We're not doing anything in particular to them. We're just listing them. We're saying this is our group of numbers we're talking about. We talked about different sets of real numbers. We talked about natural or counting numbers, 1, 2, 3, 4, 5, and so on. We talked about whole numbers, which include 0, 1, 2, 3, 4, 5, and so on. And we talked about integers, which are all numbers, positive, negative, and 0, that don't have a fraction or decimal part. So -3, -2, -1, 0, 1, 2, 3, and extending forever in both directions. We talked about absolute value, where absolute value, and if it's negative, it becomes positive. If it's positive, it stays positive. And we talked about adding together signed numbers, where adding a negative is really the same thing as subtracting. And we always got to pay attention to our sign.
Are you gonna have 30 tests?
30 tests, we're probably not going to get up to lesson 120. So, no.
No, I was saying like there's 100, so we're going to get less.
No, last year I got up to 80. But
But that was a coronavirus.
that was with coronavirus, right? Okay, so lesson 6, we talked about adding together. We talked a little bit more about adding together positive and negative numbers. When we've got more than 2 of them, we can add the positives together, add the negatives together, and then we've got 1 positive, 1 negative. We can combine those.
Whoa.
Amazing, isn't it?
I know.
Because addition, we can do in any order. Okay, we talked about subtraction being adding a negative. Yeah.
So like, you know how like multiplication is the opposite of division?
Yes.
And you know, yeah. And multiplication is like similar to adding.
Yes.
Yeah. So you can do both in different orders. Like you can multiply and add in different orders. And you can also
Yep.
Alright.
Yep. Right. Multiplication is repeated addition. We can add in any order, so we can multiply in any order. Division is repeated subtraction. Subtraction has to happen in a certain order, so division also has to happen in a certain order. All right, so then in 7, we talked about the opposite of a number, means we just 3. When we have multiple negative signs, they cancel out in sets of 2. So if there's 1 negative sign, it's negative. If there are 3 negative signs, it's negative. If there are 5 negative signs, it's negative. Odd number of negative signs, whole thing's negative. Even number, 0, 2, 4, 6, 8, etc., whole thing is positive because they'll cancel out in sets of 2. That was it for 7. In 8, we talked about area. You need to know these area formulas. You need to know how to find the area of a rectangle, length times width. For a square, it's the same thing, length times width, except that the lengths are the same. The length and the width are the same. You need to know the formula for area of a triangle, 1/2 base times height. Because a triangle is, generally speaking, half of a rectangle. Sometimes it's half of a parallelogram, but it works the same way. 1/2 base times height. A circle is pi r squared. Do not get the area of a circle. Pi r squared, do not get that mixed up with the circumference, which is 2 pi r. Please do not get them mixed up. One way you can remember is that r squared, what are we used to seeing in area? Square units. So if we're squaring the radius, we're going to have to square units. Keep those straight, don't get them mixed up. You should know how to find the area of a parallelogram. A parallelogram, as we discussed, is really just a rectangle where part of it has been moved around. If we've got a parallelogram, like this guy, like really we could chop off this triangle on the left and stick it on the right and line up with the rectangle, which is why the area of a parallelogram is also length times width, or if you want to call it base times height, that's fine. Usually we say base and height for parallelograms, but it doesn't really matter. The trickiest one is trapezoids. A couple different ways you can think of trapezoids. You can think of it as 2 triangles. You can think of it as half a parallelogram. Either way, the area of a trapezoid is what? Somebody tell me.
Right times height. Base times height.
Nope. Base 1 plus base 2 times height, all divided by 2. Yes, this is fair game for the test. This is lesson 8.
Base 1.
Because a trapezoid, those 2 parallel sides, those are your 2 bases, and they're different lengths.
Oh, you're okay, yeah.
You take those 2, you add them together, multiply by the height, and then you divide by 2.
Wait, what is that for the top
This one?
Yeah.
This is a parallelogram.
Yeah.
The formula is length times width, which is the same as a rectangle. The reason why that works is because any parallelogram, we can chop off the slanty part on the left and stick it on the right and turn it into a rectangle. Right, if I chop off this part here, it'll fit exactly here, and I'll end up with a rectangle in any parallelogram. That's why the formula for a parallelogram is the same as the one for a rectangle. You don't need to know that particular fact, as long as you know how to find the area of a parallelogram.
So I'm 2 base.
Base times height or length times width, whichever you want to call it, yep. For a trapezoid, this is the tricky one. The bases of a trapezoid are the parallel sides. Notice, be careful. If we took the same trapezoid and we turned it around this way, where are the bases?
What, the side?
The left and the right.
But
Right.
they can't stand them.
It doesn't have to stand, it's a flat thing. It exists on a sheet of paper. It exists in 2 dimensions. The base is not necessarily the bottom side. That's something we're going to have to keep in mind throughout this year. Because the shape, we can take it and turn it. Is that going to change the area if I rotate it around? No. The bases of a trapezoid are the 2 parallel sides.
There's a height of it.
No, the bases are the 2 parallel sides. Notice this is parallel to this. That's base 1 and base 2.
Oh,
Exactly, right? They're never going to touch. If you send them further, they're never going to touch. The height is the distance between the bases. The height is the distance between the bases. Incredibly ugly. It's a little bit better. Notice the height here is the distance between the bases. Here also, height is the distance between the bases. It doesn't matter how this trapezoid is arranged. I can even have it sort of like this. Okay? Well, it's resting on that. That's at the bottom. Still not a base. The bases are my parallel sides. And the height is still the distance between them. Base 1 plus base 2 times height. So base 1 plus base 2 first, inside parentheses, you add them first. Then you multiply that by height, and then you divide by 2. The whole thing by. Right, we add them together. The reason why this works, I think I've shown this to you guys before, but I'll show it to you again. The reason why this works is because what this formula does is it says, okay, trapezoid. We've got a trapezoid here. All right. Let's say it looks like this. This is a trapezoid. Notice it's got 2 parallel sides. It's got 4 sides total. What this formula does is it says, well, let's make another one of those and stick it here. Now what kind of shape do we have? Not a rectangle, because these are sloped. Right, this isn't 90 degrees. So what kind of shape is this? It's a parallelogram. How do we find the area of a parallelogram? Base times height. What's the base of this parallelogram? Oh, look, it's base 1 of the rectangle plus base 2, right? That shorter base, and then the longer base, because it's flipped upside down here. Base 1 plus base 2, and then how do we find the area of this? We take the base and we multiply by what? The height. This is the same as the height of the rectangle, of the trapezoid. So now I found the area of this parallelogram, but how many of the trapezoid is this parallelogram made up of? 2 of them. So I'm going to take this and I'm going to do what to it? Divide it by 2. There we go. That's where that formula comes from. Perimeter of a rectangle with a semicircle. Yes, we can do that too. So you should know the basic formulas for all of those. And then also be ready to deal with problems where we're combining some of them. So for example, if we have one of these rectangles that has a semicircle on the end of it, we should be able to find the perimeter of this or the area of this. So let's say this is 10 and this is 6. So let's find the area first, because we were just talking about area, and then let's talk about the perimeter. So to find the area of this, what are we going to have to add up together?
The area,
The area.
10 times 6.
So that's 1, that's area 1. Okay, area 1 is 10 times 6, because what kind of shape is that?
That's square.
Not square.
I don't know.
What type of shape is this? It's got How many sides?
Yes.
4 sides. It's got right angles. It's not a square because
Oh, they're different. Yeah.
they're different. So it's a rectangle. But still, length times width. So the area of area 1 is 60. Let's say that these are inches. 60 square inches. Okay, but that's only part of the area. What else do we still need to find the area of this?
The half circle.
The half circle up top. We'll call that area 2. How are we going to find area 2?
5 times.
Yeah.
What kind of thing is area 2?
10.
It's a semicircle. So how are we going to find the area of a semicircle?
R
Don't use any numbers. Just tell me the formula for the area of a semicircle.
pi times R squared.
Pi r squared divided by 2, right?
Mhm.
Pi r squared would be the whole circle, and this is only half it, so we divide that by 2. What's the radius here? That's what we still need. We know what pi is, we know what 2 is. We need the radius. What's the radius of this semicircle?
5.
What was that?
5
How'd you get 5?
was the line right there is 10. 25 by 2 is 5.
Exactly, because the diameter is 10. All the way across is 10, so it's 5. So we get pi times 5 squared divided by 2. Okay, so we get 25 over 2 pi. The area of the whole thing is 60 plus 25 pi over 2 square inches. There's your area. What about the perimeter? We want to find the perimeter. Perimeter of this, what are we going to add together?
12 and 10.
Where'd you get 12 from?
That's 6.
Yeah, because this is 6 also. We're going all the way around. So we need 10 plus 6 plus 6 plus, what's this?
5 pi.
5 pi. Yes, where'd you get 5 pi from? Where'd you get 5 pi? The semicircle. So what did you do to get that? It's correct. Yes, so the circumference of a circle is 2 pi r. So the circumference of half a circle is just pi r. We divided by 2 is pi r. And the radius, as we said before, is 5. So 5 pi, 10 plus 6 gives us, anybody? 10 plus 6 plus 6.
22.
22. You should know how to find the perimeter of something like this and the area. Notice with both of those, the trick is remembering that this is half a circle here. All right. Questions, comments, concerns? Okay. You can, I should have some free time this afternoon. You can stop by in here or find me elsewhere and ask questions to review for tomorrow's test. We'll talk about 12 probably on Monday. We'll do 12 and 13 together. Bye.
Wait, so even though it's the area, wait, why do you have 60 plus 25?